Okay, good day, my dear students. Hello, everyone. Please join me as we have the discussion about finding the inverse of a matrix by applying the concepts of the adjoint and the determinant of A. Okay, in the previous chapter, we were able to get the inverse of a matrix using the concept of reduced row echelon form of a matrix. So this is an alternative way of finding the inverse of a matrix, and this will necessitate our knowledge about finding the adjoint of a matrix and finding the determinant of a given matrix. So as a review, we were able to define adjoint of A in our previous meeting. We were able to define adjoint of A, okay, such that the adjoint of an n by n matrix A is also an n by n matrix, which is formed by getting the transpose of a square matrix whose entries are the cofactors of every of the corresponding entries of matrix A. Okay, so let us have an example of that as a review. So let us consider, say, matrix A, whose entries are, say, 1, -2, 3, oops, and then 2, 0, 4, and 5, -1, and -2. Okay, so we have this matrix. Okay, and let us find the cofactor of each of the entries of matrix A. So let's start with A11. A11 is equal to -1 raised to 1 plus 1 times the determinant of a matrix formed by deleting the first row and the first column of matrix A. That's how we get the cofactor. So that is 0, 4, -1, -2. So this is equal to -1 raised to 2 is +1. And then let's get the determinant of this, that is 0 plus 4. So this is equal to +4. So the cofactor of 1, or the cofactor of A11 is equal to 4. So we will be needing this later. Okay, how about A12? So A12 is equal to 1 raised to -1 raised to 1 plus 2 times the determinant of a matrix form or a submatrix form by deleting the first row and the second column. So we have 2, 4, 5, -2. 5, -2. So this is -2. So this is equal to -1 raised to 3, that's -1, times 2 times -2, that's -4, minus 5 times 4 is 20. So -4 minus 20 is -24, multiplied by -1, so that is +24. That's A12. Next, for A13. A13 is equal to -1 raised to 1 plus 3 times the determinant of a matrix formed by deleting the first row and the third column. So we have 2, 0, 5, -1. 2, 0, 5, -1. So this is equal to -1. This is 1 plus 3. 1 plus 3 is 4. And -1 raised to 4 is +1. Times 2 times -1 is -2, minus 5 times 0 is 0. So this is -2. So this is A13. Well, let's get the cofactor of the next row of the each entries in the second row. To say, let's get A21. A21 is equal to -1. This is -1 raised to 2 plus 1 times Okay, we will delete the first row and the second row in the first column. We have negative 2, 3, negative 2, positive 3, and then negative 1, negative 2. So this is equal to, this is negative 1 times 4 plus 3. So this is equal to negative 7. That's A21. Next, let's take A22. So this is negative 1 raised to 2 plus 2. Okay. Times, so 2, we have 1, 3, 5, negative 2. 1, 3, 5, negative 2. And we will get the determinant of this. So this is equal to positive 1 times negative 2 minus 5 times 3 is 15. So this is negative 17. Then A23 is equal to negative 1 raised to 2 plus 3 times the determinant of a matrix form by deleting the second row and the third column. So we have 1, negative 2, and 5, negative 1. 1, negative 2, 5, negative 1. So this is equal to negative 1 raised to 5, that's negative 1, times 1 times negative 1 is negative 1, minus 5 times negative 2 is negative 10, so that is plus 10. So this is equal to negative 1 plus 10 is 9. 9 times negative 1 is negative 9. So this is A23. This one is A22. Okay, let's get the cofactors of the entries in the third row. So A31 equals negative 1 raised to 3 plus 1 times, okay, let me move this a little more. Okay, times the matrix form by deleting the third row and the first column. So we have negative 2, 3, 0, 4, negative 2, 3, 0, 4. So this is equal to negative 1 raised to 4, that's positive 1, times negative 2 times 4, that's negative 8, minus 0 times 3 is 0. So negative 8 minus 0 is negative 8 times 1, that's negative 8. Negative 2, 3, 0, 4. I'm just checking the sign. Negative 8 minus 0 is negative 8 times positive 1, that's negative 8. Next, A32. A32 is equal to negative 1 raised to 3 plus 2 times the determinant of, remove the third row and the second column, 1, 2, 3, 4. So 1, 3, 2, 4. So this is equal to negative 1 times 4 minus 2 times 3 is 6. 4 minus 6 is negative 2 times negative 1, so that's positive 2. Then what's this? 3 is equal to negative 1 raised to 3 plus 3 times the determinant of 1, negative 2, 2, 0. 1, negative 2, 2, 0. So this is equal to negative 1 raised to 6 is positive 1 times 1 times 0 is 0 plus 2 times 2 is 4. So this is positive. So these are the cofactors of each of the entries of matrix A. So this is A32. Let me label this. This is A31. A31 then this is A3, 2, then this is A3, 3. So this is a recall on how we get the cofactors. Then afterwards, if we will get the adjoint of this matrix, let me use another pen, another color. So the adjoint of matrix A, in finding the adjoint, first we will form a 3 by 3 matrix whose entries are the cofactors of this, okay, of matrix A. So we have 4, 24, -2, and then -7, -17, -9, -8, +2, and +4. Okay, adjoint of A, we have this matrix, but we'll get the transpose of this. So the adjoint of A is equal to 4. This is -7. And then this is -8. Then this is 24. Then this one is -17. And then this is -9. 24. And then that's 2, I think. This one is 2. Okay, mali ang natingnan ko. So 24, -17, and 2. And then this one is -2. This is -9. And this is 4. So this is the adjoint of A. Okay, so yan yung napag-aralan natin last meeting. Now, let us proceed with this theorem. If A is an n by n matrix, then A times the adjoint of A is equal to the adjoint of A times A, which is equal to the determinant of A. So I want you to verify this one. Okay? So we have matrix A here, and then we have this adjoint of A. So when we multiply these two, we will get the determinant of A. So, we'll get the determinant of A. Sige na nga, gawin na natin. So, this is matrix A. So, first, let's get the determinant of A. The determinant of A is equal to, okay, by Sarah's rule, this is 0 plus -2 times 4 times 5 is -20 plus 3 times 2 times -1 is -6 minus 5 times 0 times 3 is 0 minus -1 times 4 times 1 is -4 minus plus -2 times 2 times -2 is +8. Okay. Let me double check. This is 0, 2, 4, and 5. Okay, that's 40. -2 times 4 is -8 times 5 is -40. And then 3, 2, 1, that's -6. Then we have this is 0, -1, 4, 1, that's -4. And then -2 to -2, that's +8. But we will take minus sign. So this is equal to -40 minus 6, -46, plus 4, -42, minus 8, -50. So the determinant of A is equal to -50. Now, ano yung kiniklaim nitong theorem na to? A times the adjoint of A is equal to the determinant of A. Okay, so A is -1, 2, 3, 2, 0, 4, 5, -1, 2. So tingnan nga natin, let's multiply. Again, ang A is A times the determinant of A. A is sorry. A times the adjoint of A. Oops. So, yan likod ng screen ko. A times the adjoint of A. Taas ko ng konti para kita natin. A times the adjoint of A is equal to yung A natin is a matrix whose entries are 1, -2, 3, 2, 0, 4, and 5, -1, -2. This is -2. So this is A. Then the adjoint of A is this one. 4, -7, -8, 24, -17, 2, -2, -9, and +4. Okay, so A times the adjoint of A. So we will perform matrix multiplication. So 3 by 3 multiplied by a 3 by 3. So the product is a 3 by 3 matrix equals. So 1 times 4 is 4 plus, okay, recall natin, row times column. So 1 times 4 is 4. -2 times 24 is -48. Plus, 3 times -2 is -6. -6. Okay. So I'll just use this -6. -6. So this is equal to 4 minus 48 is -44 minus 6, -50. Okay, so first row, second column, we have 1 times -7 is -7. 2 times -2 times -17 is +34 minus 3 times 9 is 27. -7 plus -27 is -34 plus 34. That is 0. Next, first row, last column. 1 times -8 is -8 plus -2 times 2, that's -4. I'll just write -4 here. Plus 3 times 4 is 12. So -8 plus -4 is -12 plus 12. That is 0. So I might close this as well. For the second row, first column. 2 times 4 is 8 plus 0. 4 times -2 is -8. So 8 plus 0 plus -8 is 0. Next, second row, second column. 2 times -7 is -14. 0 times 17 is 0. 4 times -9 is -36. -14 plus 0 is -14 plus -36. This is -50. Okay, next. Second row, third column. 2 times -8 is -16 plus 0. 4 times 4 is +16. So -16 plus 16 is 0. Okay, next, third row, first column. 5 times 4 is 20. -1 times 24 is -24. -2 times -2 is +4. So 20 minus 24 is -4 plus 4. That is 0. Next, we have the third row, second column, 5 times negative 7 is negative 35. Okay? Negative 1 and negative 17, that's positive 17. Negative 2 and 9 is positive 18. 17 plus 18 is 35 plus negative 35, that is 0. Okay, for the last one, first, a third row, third column, 5 times negative 8 is negative 40. Negative 1 times 2, that's negative 2. Negative 2 and 4, that's negative 8. Negative 40 plus negative 2 is negative 42 plus negative 8, that's negative 50. So, this is our product. And this is equal to, if we will express this as a product of scalar and a matrix, okay, the scalar is negative 50 times 1, 0, 0, 0, 1, 0, 0, 0, 1. And we have to take note that negative 50 is the determinant of A, and this is the identity matrix. At iyon yung sinasabi nung theorem na to. So A times adjoint A is equal to the determinant of A times the identity matrix. So we will get the same if you will do the other way around, adjoint A times A. So please verify this. Okay, you have that adjoint. You have the value of the adjoint, multiply it by A. Then you should have arrived at this one. Determinant of A times the identity matrix, the 3 by 3 identity matrix. So that's the first part of the theorem. Now for the second part, and we are particular about this and finding the inverse, and that is our goal for this specific discussion. A inverse is equal to 1 over the determinant of A times the adjoint of A. Well, actually, this one is just a consequence of the first argument. Okay, so paano nangyari yon? A times the adjoint of A is equal to, okay, I will connect this to the last one. This is equal to the determinant of A times the identity matrix. Okay, an n by n identity matrix. So we know that the determinant of A is constant. The determinant of A is a scalar. That's constant. That's not a matrix. Okay, and a matrix has an inverse if the determinant is not equal to 0. So if the determinant is not equal to 0, we can divide both sides of this equation by the determinant of A. So we will divide this by the determinant of A. So this results into a having a right-hand side of the equation by simply identity of an n by n identity matrix. But this time around, we have A times adjoint of A over the determinant of A. Okay. So these are the factors on the left-hand side of the equation. So A is a matrix. Meron tayong identity. We can multiply both sides of the equation by A inverse. A inverse, this is, multiply this by A inverse. So that will give us A inverse is the identity. So that is simply adjoint of A over the determinant of A. This is equal to A inverse times the identity. So A inverse times the identity is just A inverse. So this is actually equivalent to this, but if you want to show exactly the same, 1 over the determinant of A times the adjoint of A is equal to A inverse. Then, in a similar fashion, you can equate this one, and this one. And then this time around, you will multiply Okay, at the end, A inverse, okay, such that A inverse is equal to identity times A inverse. And you will arrive at the same equation. So we now accept that one way of finding the inverse is actually getting the inverse, the multiplicative inverse of the determinant, and multiplying it by the adjoint of A. So we will verify this using the matrix that we have. Okay, meron na tayong determinant, negative 50. Meron na tayong adjoint of A. This is adjoint of A. Okay, which is negative 4, 7, negative 4, 24, negative 4, negative 7, negative 8. So, let's see. Nako, ang layo na nito, no? So, applying that, A inverse is equal to 1 over the determinant of A times the adjoint of A. So, in the previous example, the determinant of A is negative 50. So, 1 over negative 50 times, okay. Oh, this is now a challenge for me. What is the 4, negative 7, negative 8? If we have 4, negative 7, negative 8, and then 24, negative 17 to 24, negative 17 to, and negative 2, negative 9, 4. Negative 2, negative 9, positive 4. Okay, so since this is a scalar constant, all we need to do is just to multiply these to each of the entries of this adjoint. So this is equal to, maybe I'll be needing a larger space here. 4 times negative 1 over 50, that is negative 2 over 25. And then negative, negative, positive 7 over 50. Negative, negative, positive 4 over 25. And then 24, 50, negative 12 by 2 over 25. Then we have negative, negative, so that's positive 17 over 50. Then negative 1 over 25. And then negative, negative, positive 1 over 25. 1 over 25. Negative, negative, so positive 9 over 50. And the last one, positive, negative, so that's negative 2 over 25. Let's be careful with the sign. Negative, positive, positive, negative, positive, negative, positive, positive, negative. So this is the inverse of matrix A. Okay? So paano natin mabe-verify if this is correct? If we multiply this by matrix A, the product should be an identity matrix. So try naman natin to check this one. Ang A natin, A times A inverse is equal to, ano ang A natin? 1, negative 2, 3, 2, 0, 4, 5, negative 1, negative 2. So this is A times A inverse, that's 1, negative 2, that one, negative 2 over 25, and then 7 over 50, then 4 over 25. Then negative 12 over 25, then 17 over 50, negative 1 over 25. This one is negative. Then 1 over 25, 9 over 50, and negative 2 over 25. Okay, let's perform multiplication. So this is 1 times negative 2. So, puro over 25 naman. So, sa numerator tayo. 1 times negative 2 is negative 2 plus 24. Negative 2 plus 24 plus 3. Okay? So, negative 2 plus 24, that's 22 plus 3, 25 over 25, that is 1. Next, o ito naman, puro 50. So, 7 minus 34 plus 27. 27 plus 7 is 34. Minus 34, that is 0. Next, dito, puro over 25 naman. So, okay, para numerator na lang intindihin natin. 4 plus 2 is 6. 6 minus 6, that is 0 over 25, still that is 0. Okay, second row, first column. 2 times negative 2 is negative 4. Plus 4 times 1 is 4. So that is 0. Kasi ito magzi-0 na. Next, second row, second column. 14 plus 0 is 14 plus 36. 14 plus 36 is 50 over 50. So that is equal to 1. Next, 8 plus 0 is 8 minus 8. That is 0 over 25. So that is 0. Next, third row. Negative 10 plus 12 is 2 minus 2. That is 0. Next, 35. 35 minus 17 minus 18. Negative 17 plus negative 18 is negative 35 plus 35. That is 0. Last, 20 plus 1, 21 plus 4, 24. 21 plus 4 is 25. 25 over 25 is 1. So the product is an identity matrix. So on your part, you try getting A inverse A at dapat makukuha nyo din ay identity matrix. So this is how we get the inverse. Ano ang gagawin? Ang mga elements dito, ingredients, kailangan natin ng determinant ni A, this one. Kailangan natin ng adjoint of A. Well, actually, yun lang ang kailangan natin, ano? And it so happen, medyo mahaba ang pagkuha ng adjoint of A. Yung determinants of A, medyo okay na. But if we know the determinant, if we know the adjoint of a matrix, then we can get the inverse by getting the product of the inverse of the determinant and the adjoint of matrix A. So you have additional example here, okay, sa ating lecture notes. So i-add nyo na lang itong example na to dito sa recording, and please practice what you've learned from this video, and just enjoy learning. Thank you for listening, and have a nice day.